Section R.2 is about operations on real numbers. So, when we're adding numbers with the same sign, this is the way it describes it in the book. I also like to think of it as a number line, right? Okay. But when we're adding numbers with the same sign, it says to add the absolute values and use the common sign of the sum. So, for example, if I'm adding -7 and -11, I would add the absolute values of 7 and 11, and then keep the common sign, which is a negative. You can also think of this as -7 instead of plus, but -11. You can also use a number line, whatever helps you add and subtract negative numbers. So this would be -7 plus 11, which is -20. 8 and 4, again, I'm sure you know how to add these, but it's telling us, the text suggests to take the absolute value of both numbers and then use the common side. So because both of these are positive, I'd have a positive 8 plus 4, which is 12, which felt really redundant. But if you're having issues with, not issues, if you're having difficulty understanding how to add negative numbers, this is a great place to start. When we're adding numbers with different signs, what we want to do is we want to subtract the smaller absolute value from the greater absolute value. And then you use the sign of the number with the greatest absolute value. So if I have -13 plus 4, I would take I would subtract the absolute value of 4 from 13, and then I keep the greater sign, which is a negative. So I'd have -13 minus 4, which is -11. And you might be like, oh my gosh, Professor Miller, why are you describing it this way? Well, I'm describing it this way because this is the way it mentions in your text. It's the way it's going to be worked out in my math lab. But in my personal opinion, I would take a number line. And if I go to -13, and I'm at -13 on my number line, and I say, okay, I have to add 4, I'm going to go 1, 2, 3, 4. Well, that would put me at, that's a 9. Why did I say 11? See, even this confuses me. That puts me at a -9, right? If I move 4 more to the right. So that's the way I would do this. I would also, if you've got a larger positive number, rewrite this instead of plus -12, rewrite that as -12 to get your answer of 32. When you're working with positive negative numbers, treat it like money in your bank account. If I have $13 and I deposit $4, I've got -$9. If I have $44 and I buy a $12 cup of coffee, because apparently that's how much coffee is nowadays, I would have $32 left. So that would be my suggestion, but I wanted to briefly show you how it's gone over in the text. My apologies if I just confused everyone on how to add. Subtraction is known as finding the difference. Okay, the difference between any two numbers, a minus b, is the same as a plus a negative b. That's how I could rewrite in the previous example 44 plus a -12 as 44 minus 12. It's finding the difference. So the text says that when we're subtracting real numbers, we need to change the subtraction operation to addition and use the rules for adding and subtracting numbers of different signs, i.e. that absolute value method. I don't think that's the most beneficial method. Think of it as a bank account. Think of it as a number line, okay? If I have $20 and I spend, so I subtract $33, I'm left with a -$13 in my bank account. If I'm at -5, it's -5, and I subtract 2, so I'm going 2 more to the left, right? So we've got negative numbers over here and positive numbers over here. That puts me at -7. If I have 9 minus a -12, well, minus a negative is the same as adding, right? We can put these two together. So I've got 9 plus 12, which is 21. Let's talk about additive inverses. Every real number has an additive inverse. So for every number a, there exists a number negative a such that a plus negative a is 0. We call these two numbers additive inverses. Any numbers that add up to 0 are inverses. So, except 0, 0 doesn't have an inverse. So the additive inverse of 0.25 would be negative 0.25. The additive inverse of negative 1/4 would be positive 1/4. The additive inverse of 5 would be negative 5, because if I took the sum or added these, they would add up to 0. Let's talk about multiplication. Multiplication is really repeated addition. If I went 5 times negative 3, that's really telling me to add negative 3 5 times. And I would get a negative 15. 5 times negative 3 is negative 15. The result of multiplication, when I multiply any two numbers, is called our product. And the numbers being multiplied are called the factors of the product. Let's talk about how to find the product of two real numbers. And again, this should be review. The product of two real numbers with different signs is found by multiplying their absolute values, and their product is negative. The product of two real numbers with the same sign is found by multiplying their absolute values, and their product is positive. So like negative 2 times negative 2, two negatives giving a positive, it's going to be positive 4. 3 times 4 is 12. It's going to be positive. If I've got negative 2 times 6, that's going to give me a negative 12 because I've got one negative and one positive. Or if I have 5 times negative 1/2, that gives me negative 5/2. Again, the answer is negative. When I'm multiplying by 0, though, it's important to note that the product of 0 and any real number is 0. So for any real number, positive or negative, 8 times 0 is 0. So negative 4/5 times 0 is 0, and 5 times 0 is 0 as well. So let's go ahead and find the product. So remember that when we multiply fractions, which we'll talk about in a bonus video, you multiply the numerators and you multiply the denominators and simplify. So negative 3 times negative 9 is a positive 27. 6 times negative 4 is a negative 24. Negative 0.5 times negative 0.4, that's going to give us a positive 0.2. Negative 0.2 times a 0.3, that gives me a negative 0.06. 1/2 times 3/4, we multiply our numerators, multiply our denominators, and simplify if we can. If I have negative 2/3 times 1/5, that's going to give me negative 2/15. If I have negative 3 times negative 5, that's going to give me a positive 15 over 4 times 6, which is 24. Both of these have a factor of 3, so I get 5/8. Again, I pulled out a factor of 3. Check out our bonus fraction video. Next, I want us to talk about reciprocals. So two numbers whose product is 1 are said to be reciprocals. These are also called multiplicative inverses. So before, we had additive inverses, which add up to 0, and multiplicative inverses multiply to 1. So the reciprocal of 3/7, for example, is 7/3, because 3 over 7 times 7 over 3 gives us 21 over 21, which is 1. I.e., you flip the fraction and make it a reciprocal. Note it says that the two numbers products must be a positive one, so they're always going to have the same sign. Reciprocals have the same sign. I think that's important to note. So every number has a reciprocal but 0. 1 is its own reciprocal. That's kind of boring. But every number has a reciprocal but 0, because you can't multiply 0 by anything and get anything other than 0. Reciprocals of whole numbers are fractions with 1 in the numerator. For example, 5 times 1/5 would be 5/5, which is 1. The same holds true for integers. So if I had negative 3 Its reciprocal would be a negative 1/3. Again, they gotta have the same sign. That would give me a positive 3/3, which is 1. I have a note right here that I mentioned earlier. The reciprocal of a negative number is also a negative number. So given a real number a, there exists a real number 1 over a such that a times 1 over a is 1. So state the multiplicative inverse of the following. So if I have 1/4, its multiplicative inverse is going to be, you could write this out as 1 over a. So for example, for problem 2, its reciprocal would be 1 over -5. In this case, it's a fraction, so we're just going to flip it. Its reciprocal is 4 over 1, which is just 4. If I have negative 0.25, ooh, that's a little bit different. Maybe we should set it up like this. I've got 1 divided by negative 0.5. Well, 0.5 is a half. That gives me negative 2. Let's check our work. Negative 2 times negative 0.5. Oh, that was, okay. So let's differentiate between a decimal and a multiplication symbol. So real quick, some folks as multiplication symbols use this like really big X, right? Like this right here. But as we move on in this class and we start to use X as a variable, you'll also see us use like a little closed dot. I'm going to use a parenthesis right now. So I have negative 2 times negative 0.5, which is negative 1. The reciprocal of 5/8 would be 8/5. The reciprocal of 3/2 would be 2/3. You just flip the fraction when you're given a fraction. Otherwise, with a decimal, you do need to solve by setting it under 1.